All right, it is 6:55, that's 25 minutes in. So I'm going to go ahead and start diving into tonight's proposed Plotly Dash app. Though I know that a lot of folks are probably still working on it, but you've sunk your teeth into it a little bit, you've given it a try. Now let's go ahead and talk through some of this together as a group. A couple of house cleaning tips first before I forget. So we are now 2 weeks away from our last class. Thursday, November 7th, you'll be presenting your final projects. And the idea is that the final project will be something quite similar to what tonight's app was. That basically you will have a working Plotly Dash app successfully deployed in Heroku that has a Pandas data frame, some sort of visualization of the data, and some sort of interactive callback. Those are the 3 things or 4 things that I'm looking for. Pandas, visualization, callback, deployed on Heroku. And if you put this together, this is actually very similar to a final project that I got from a student back in June that I went ahead and I riffed on afterwards, but he was the one who collected and cleaned all the data. So that's what I'm looking for, and I'm hoping that everybody will be able to successfully demonstrate that in Thursday's class 2 weeks away. So right off the bat, hot off the press, just questions, comments, thoughts about where you stand vis-a-vis the final project right now. Everybody's clear on kind of what the expectations are? I will say, for whatever reason you end up not being able to deploy on Heroku and you just have to, you can make it run locally, I'm cool with that. Just bring your laptop up here and plug it in and just show us that you can make the thing work. that's A-okay. But if you can actually get it running on Heroku, even better. Secondly, next week's class, Tuesday and Thursday, as I mentioned in the previous class, I would like to have class from 6 until 8 instead of 6:30 to 8:30. So far, no one has shown any objections to that. So I'm going to go ahead and move forward with that plan. Please speak now or forever hold your peace on that one, okay?
What day?
So next week is Tuesday and Thursday?
On both days?
Yes, on both days. Yeah.
You mentioned either starting right at 6:30 and doing the other part's homework versus starting at 6 for 30 minutes like this.
Yeah, so I will be here in this room from 6 until 8.
Okay.
But the first 30 minutes, as you've seen me do, is just the usual Plotly Dash activity. So if you feel like doing that on your own or just skipping it entirely, I'm obviously cool with that. And I will record the whole thing for what it's worth, just as I've been doing every other class. But I just need to get home by 9 o'clock both nights. That's all, for a variety of reasons. So thanks for that flexibility. All right, so I understand that this Dash Plotly Dash app that I tossed out tonight is actually probably a lot more complicated than what you could do in 30 minutes. And I know Jason and I were corresponding earlier during the day. This is a lot. It's a lot to bite off. But I wanted you to at least have a taste of it and get a sense of kind of what this would be like. I'm actually asking you to tackle here what is the size of an entire final project. But let me talk through it and break it up into some bits and pieces. And then a couple of people have slacked me and said, I would really like some more time talking about callbacks in particular and Dash apps in general in order to get ready for the final project. So kind of on that note, I'd like to spend tonight's class building out a couple of Dash apps basically from soup to nuts. There's a lot of visualization in there. There is a lot of pandas. But I wanted to do this now rather than next week so that you can use the knowledge as you work on your final projects. So what we're going to do is we're going to actually build out a couple of examples in tonight's class, basically from scratch. And then on next week, I will continue with Repository 11, which is a few other tips and tricks for Pandas data visualization. Okay?
Did you record it so we can watch it?
I'm recording right now. Yeah. And I'm pleased that that's been helpful. I know. Okay, so this particular one has the counties of Virginia with a drop-down, and you can choose any county, and it will show you the 2016 presidential election by all the precincts in that county. So if you were to choose Arlington, for example, Arlington has apparently one really big precinct and a lot of really small ones, or Fairfax County also has a lot of, I didn't actually realize that. How about Fairfax City? I'm trying to get one. There we go. That's what I was looking for. So Fairfax skewed predominantly for Clinton, secondarily for Trump, and then all other candidates are grouped into that third category. And we can see this for each one of the precincts across, plus the absentee precinct for each one of them. And what's nice about this visualization, in my opinion, is that it takes a fairly complicated data set, summarizes it into a bar chart that's easily readable by a layperson. Anybody can quickly understand what they're looking at here, but it has this nice interactivity from the drop-down. But it's not too complicated. You know, a full production level, what am I trying to say, dashboard probably would have a lot of tabs and a lot of interactivity. This one just has the one drop-down and the one visualization, so it has all the elements that you would need in order to build out a much more complicated dashboard. So let's talk about how this one is built. And then the challenge was basically do anything with it, but the stretch challenge was to add a dynamic map of Virginia highlighting the specific county selected by the user. And I understand this is stuff I actually worked on it quite a bit myself and had some challenges with it. But the end result would look something kind of like this. So you have the same drop down at the top where you can select any county. And then down at the bottom you have the same grouped bar chart with all of the precincts. But in the middle we have a map of Virginia, just quickly highlighting what the county is. And in this one the default is Bedford County. And if we were to select any other county, so once again we can go with Fairfax City, and it takes a minute to update. And now we see Fairfax City is quite small, but it's highlighted there in yellow, which we can zoom in on. And it's got those vote totals for Fairfax. So this would be kind of the gold standard of what it would be great for you to be able to do to build out on this app. And just out of curiosity, Aiden, I'd like to see what you were able to put together on this one, as you were one of the ones who were able to check it out.
I didn't do the math. I just added an additional drop down where you can select.
An individual candidate, nice. Right, so rather than the grouped bar chart, we have this broken out bar chart for each one of the. Excellent. Okay, so let's talk a little bit about how we would build this. So I'm here inside my repository, and there's a number of files here. There's actually 3 versions of the app. app.py, which has the bar chart, app2.py, which has only the map, and then app3.py, which has both the bar chart and the map together into the same dashboard. There's also a couple of Jupyter notebooks where I did my exploratory analysis and kind of kicked the tires on it a little bit, and then a number of data files to explore through as well. Let's get started with the Jupyter notebook. And this is all at high level, but in a minute I'll ask you to kind of build out some of this with me. Right now this is just sort of orientation. Okay, so here's the same thing but in Jupyter. And we have, the first one is the exploratory notebook. And this is very common in my workflow and what I've seen others do as well, is that inside your GitHub repo, you do your exploration in a Jupyter notebook that will never get deployed, but it's there so that people who go exploring into your code, hey, how's it going? People who go exploring into your code can see what your preliminary steps were, but then your final product will be your .py file. So in this notebook, and again, we'll do a code along in a little bit. Right now, this is still at a very high level. I've got my imports. I read in my data file, which is Virginia. I restrict it to only a few columns, and we merge in some FIPS codes. This was necessary for the map. The map requires that for every county, it has the county code that goes with it. So there's a step here where I merge in those codes into the election data. And we end up with something like this. Following a group by statement, we see the county, its FIPS, and its full name, a column with its individual precincts, a column with each of the candidates, and then the votes total is actually the only, and this is a curious setup for a Pandas data frame, this actually has a 5-level index. The first 5 columns are all just index columns, and then the body of the data frame is only 1 column votes. So that's what it's built around. It's a very slim body with a very large index. The Pandas unstack method is a good way for handling a multi-index, grouped index data frame. And then this was just a little bit of exploration. For here, for example, I wanted to see what would happen. Now let me talk about unstack for a minute. What unstack is doing is originally there's just 1 votes column with votes for Donald, Hillary, and other. Unstack breaks those 3 out into their own unique columns. So in the result, you see there's a column for Trump, a column for Clinton, and a column for other. That's the purpose of unstack, is to take a vertical column and to break it out into, whatever the number of actual columns is that's nested in there. Sort of like pivot tables in Excel, if you're familiar with that. They're not exactly the same.
So what's the level argument? Like level equals -1.
So level is referring to the index. -1 means the last index, whatever the one furthest to the right is, which in this case happens to be candidate. Because I could have unstacked all of it, county name, fix, jurisdiction, and precinct, which would have been an awful lot of columns, but I don't actually want that. I only want to unstack the last index column, which in this case is candidate.
Okay.
And -1 is similar to the Python indexing you've seen in the past, where -1 means whatever is at the very end of the list.
All right.
Okay, then we reset the index, because otherwise, if we don't do that, then, why did I do this? I don't actually remember why I reset the index, but what it did was that it actually don't know why I did that. But I'm just going to move on because it's probably not important. Okay, and then just a little bit of exploration into what's going on here. I wanted to find out what are my columns. I wanted to see what does an individual cell looks like. So again, this is just data exploration. What does an individual jurisdiction look like? And then what would happen if I were to filter onto an individual county? And this cell 12, is important because this is what my function will be doing once I get into the app. My drop-down will select a particular county name, and then it will filter the data set based on the selected county. So I'm trying that here first simply by hard-coding a single county in order to see what the result will be. And the resulting data frame is 4 levels deep. It looks like, no, that's just because I called ahead. It's probably deeper than that. But it has all of the precincts and all of the votes, but only for a single county, which in this case is Accomack. And this resulting data frame is what my drop-down will produce once I put into this into the app, because I'll substitute Accomack with whatever was selected by the user from the drop-down. Based on this, then these numbers over here on the far right, this is what's going to get displayed in that grouped bar chart. 644, 784, 59, those are going to be the orange, blue, and green columns respectively. Then this is a step in order to get the full list of precincts, which will be displayed across the bottom of the graphic. My x-axis should be the name of the precincts, but I need this to be automated for any particular county. So again, because I previously selected Accomack as my county of choice, now I can call value counts on the precinct variable, and by calling the .index method, I get all of the labels of the value counts regardless of what the actual values was. Then this will be turned into the x-axis of my later graphic. Likewise, in cell 14, I do the same thing, but I'm going to build this out as the body of the content, of the numerical content of the graphic that'll come later. I choose some colors, and now all of this gets built into a Plotly graphic, which will display the following grouped bar chart, but only for Accomack County. So let's talk about what's going on here. So it is a bar chart, and as we've seen in Plotly figures up until now, we have the data comes first, the layout comes second, and then we use the go.figure method to combine data and layout into a single figure that will then get displayed. So data plus layout grouped together using go.figure displays our Plotly-figure for us. Now inside the bar chart, the syntax is I've got my X data for the x-axis of the graphic. I've got my Y data, and then I've got the marker data, which is specifically the color and the label that will hover over the bar chart when I select it. And clearly we can see these two lines, the X and Y, these just correspond to the previous 2 cells in the Jupyter Notebook that I was playing around with a moment before. The value counts.index provides the labels for my x-axis, and the filter on Accomack votes Donald Trump provides the numeric values that go into the bar chart. And clearly, Trump is the first set of data, Clinton is the second set of data, and other candidates the third set of data. And other than that, and the difference in color, my data 1, 2, and 3 are identical. So clearly, the only thing that needs to change here is the name of the candidate. The rest of the code is going to be identical. And then I use, just because it's a Jupyter Notebook, I use the iplot syntax. That's not necessary in Plotly Dash, and it produces the grouped bar chart for Accomack County, which looks like it trended overwhelmingly for Trump. Not overwhelmingly, some places did. Now the next step in cell 17 is to take all of that same code and turn it into a function that can be automated for any county. So all of this code is pretty much identical to the previous cell, with the exception that I took a function and I feed it in the name of the jurisdiction or juris name. And then I have this initial step right here of filtering down the data set to where the jurisdiction column is equal to the juris name that was fed into the function. Everything else is going to be the same, except that instead of Accomack County, it's now jurisdf for whatever county was selected. So all of this is a function. Again, it's virtually identical. And now if I choose a different county, York County, then it will display that appropriate output. So this is what's going to, this fairly complicated function is what's going to get dropped into my Plotly Dash app. And I try it again for Accomack, a couple of others, and at the very end, I pickle my data file. Now this is new. Up until now, we've worked with CSV files, and we've used pandas.csv, and I could have done that here just as well. df4 to CSV, and I could have called it Virginia totals.csv, and that would have been fine. I just wanted to introduce you to a different way of getting the same end. So CSV files are universal. They can be opened by Excel. They can be opened by the MacBook data product. They can be opened by SQL. They can be opened by anything. So they are kind of universal. But because they're universal, sometimes they lack some of the widgets and functionality that a Pandas data frame would necessarily have, like automatically recognizing what the column names are. So this is an alternative that is unique to Python objects. You can take any Python object and you can save it as what's known as a pickle file. And then when you reopen it in another Python script, it has exactly the same properties as it did in your previous Python script. So specifically, because df4 was a Pandas data frame when I pickled it, Virginia totals is now also a Pandas data frame with all of the built-in Pandas methods. So that's really, it's more of a professional way of saving your data. Saving everything to CSV is sort of for beginners because we're used to that since we're maybe coming from a Microsoft world. But once you really start working on Python projects all the time, you stop using toCSV unless you need to pass it to like SQL or something like that, and you start using toPickled instead. But otherwise, they're going to feel almost exactly the same. Okay? So we save that as a pickle file, which means we can read it back, and I just test it here. I test it by reading it back in using the read pickle function, and it is clearly exactly the way I saved it as a Pandas data frame. So all of this Jupyter Notebook is what allowed me to get the pieces ready for my app in Atom.py. Questions about anything I've covered up until there? All right, then we're going to go ahead and we're going to fire up Atom, and we're going to try and build this app out now that we've kind of explored it a little bit using the Jupyter Notebook. So what I would like you to do is go to GitHub. I guess you would have to go to the original one and go to the code on GitHub, and I can also Slack this out. Oh, look, it's right there. And if you haven't already done so, be sure to clone this. Please clone to your laptop using git clone. And we're going to actually build this app out. First the bar chart, then the map, and then the two of them together. Actually, repositories. Actually, hold that thought. It's good to clone that one down because that has all the solution code. But really what I was hoping to do was to build this out completely from scratch. So what I'm going to send you is a template, and we're going to start from there. And the idea on this repository is that it has a very simple template for building a Dash app from scratch. So as you build out your final project, you might want to actually start from this template. So please go ahead and actually please clone this repo instead, or both of them together, and we'll start from the template app. and respond with emoji when ready to go. And of course, you'll want to fork before you clone, obviously. Here for those emojis. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm in Dash template, and let's take a look at what's in here. It has everything you need to get a good Dash project started. It's got your assets folder, which has just the favicon in it. It's got a git ignore, so that you don't accidentally send stuff up to Git that you don't want to. It's got proc file, requirements.txt, the readme, and above all, the app.py with all the basic starter code for a Plotly Dash app, including the imports. And over here in terminal, I've got the same thing. So I'm going to start out with Python app.py locally in order to see what this looks like in terms of a template. It's running on 127. Let's go ahead and close these guys out. So I try 127.0.0.1, and I see it's just a super simple Dash app with a title, a placeholder for stuff will go here, and then the usual footer for code on GitHub and data source. And as usual, I go to Heroku. I create a new app. Please follow along with me if you can, because we're going to iterate this through each time. We're going to create a new app, and we'll call this test template 1022 is what I'm going to call mine. And I'm walking through this so I know you're familiar with it, because understanding what the process is a key part of this, like to do things in the right order. Finding my template app, I'm connecting to it, and I'm deploying my branch. And while this is building out and you're doing your own, I'm going to philosophize for a minute here. So my thought about the flow of a Python project is within project management, you've heard a lot about waterfall versus agile, right? In waterfall, you do all the planning at the end, you do each step, you build it out completely, and then at the very end of a long project, you finally deploy. And you really only deploy once, and it assumes that all the previous steps, large as they may have been, were built out correctly. And as everybody knows from project management, that worked really nicely back in about 1987, but it's not really contemporary, especially for things like software development. With Agile, Agile is built in a So if waterfall is stepwise, right? Waterfall is stepwise, right at the very end you deploy. Agile is a spiral, starting small and getting larger, right? And every time you get back up to the deploy line, so this is where you deploy your final project, you want to deploy a minimally viable product, or an MVP, right? The smallest unit that you can successfully push out to your client or your customer. You deploy once, it works. You do another iteration, you deploy again, that works. You do another iteration, you deploy this time with more bells and features, more bells and whistles on it, and you push that out. But every time you make sure it works before you go on to the next thing. Whereas with Waterfall, you build all the features and you deploy at the very end, you show it to your client, and they're like, wait a minute, that's not what I wanted at all. Something similar, but on a smaller scale, is happening with our Python projects. If you spend a great deal of time building out your entire app, and then only at the very end you try and deploy to Heroku, and you realize this doesn't run and I don't know why, then you've got a problem on your hands, and it's hard to go and backfill that. So get in the habit of iterating with small wins. Have a simple app, a template app, push it to Heroku, make sure it works, and then go back and start adding features and continually deploy and deploy and deploy again. And that way, if something breaks, you're pretty confident you know what it was because you've been doing it in stages. So we go ahead and review our app, and that works nicely. It's got the title, it's got the placeholder, it's got the successful links. So I've got it running here on localhost and in Heroku both. Now I'm confident that I am ready to go ahead and start working in app.py. So I'm going to keep it running. And now I'm going to go ahead and open it up in Atom. And I'm going to keep my localhost running, but I'm going to make it a little bit smaller so that I've got some split screen here. And I'm even going to keep the... This is a lot easier if you have two monitors, but we're going to do our best to imitate that here. Okay, so in my template, I've got all my imports up at the top. I've got my initiating of the app here in the middle. This part never really changes. And the layout is where all the good stuff is going to go. And then finally my callbacks and the deployment statement at the end. So everything is going to go here in this primary div. And the first thing that I'll do is I'm going to get rid of the placeholder and drop in a few lines in order to open that up. And I'm going to be building out the same Virginia CSV file, or rather Virginia votes app. So for this, I actually need to move in my data file since I have an entirely new repo. So I'm going to go back to my voter data, which is in a different repository. I think that was called Virginia, what's that called? Virginia elections, CD Virginia elections. And the final data file is Virginia totals PKL. So I'm going to go ahead and move that or copy it. I'm going to copy Virginia totals.pickle into my new template app. And I'll do an ls down here. And there it's ready to go. And then I can close out the other one because I don't need it anymore. Okay, up here in my imports, I will need to import pickle, I think. No, actually I don't. I'm just using pandas. Take that back. But let's go ahead and read in the data frame first. So here at line 14, I'm going to read in my data. I'm going to call my data frame as equal to, and by the way, Megan, is this large enough there in the back?
Yeah.
Should I make it a little bigger?
I can see.
You can see? Okay, we're good? Okay. If you would like to turn off all the lights, I'm fine with that. Whatever helps people see better, as long as it doesn't put anybody to sleep. So we're going to set our data frame as equal to pandas read pickle. And it's that same pickle file that we just brought over, the Virginia underscore totals.pkl. And just to make sure that works, I'm actually going to set a print statement, print df.shape. And this is just to make sure that things ran smoothly. So I save that, toggle over here, and in fact, I can see my print statement work successfully, and maybe I even want to add a message. This is a test of my data to make sure that my data ran smoothly. Because if it can't read in the data frame, obviously it's not going to be able to do anything else. And I see that it's showing up on my output, so I know that my data read incorrectly. Now I'm going to create a list of options, and this is something that I explored earlier in my Jupyter notebook. Options list is going to be equal to, and here we can even, I'll build this out little by little. I'll start by printing data frame jurisdiction is the name of one of the columns, dot value counts, dot sort index, dot index. Save that. And blowing this up for a second, I can see that that successfully printed all the names of the counties, which is what I was hoping it would do. So now that I've printed it and I've tested it out, I'm going to save all of that as a list. That's now become a list, and I'm going to call it my options list. This is going to be the list of things that you can choose from in the dropdown. It's the index of my value counts. And that's pretty much it for Pandas stuff. Then I initiate the app, get down here into the body of all of this, and if I wanted to make sure that that was running correctly, I could simply add an HTML div, not even, simpler than that, just add options list right here under children, save it. Probably I need to turn it into a string. There we go. And that now is displaying successfully in my app. I now have a div that simply has the names of all of the counties appearing in my app because I took options list and I dropped it into that HTML div. So see how I'm trying things out little by little and then I'm building on them, and each time I make sure that it actually works in the full app. So now that I know that that works, I don't actually have to keep it as a string. Instead, I'm going to add a dropdown. So let's add DCC dropdown. And dropdowns typically have three components. They have an ID. I'm going to call this my dropdown. It's got options to choose from, which is always a list. And it's got a default value, which in this case could have been anything. I'm just going to set it equal to Fairfax County. Fairfax, or even city is my default, because that one actually displayed pretty nicely earlier. But what are the options? Well, we can build options out the long way. It always has to be label Fairfax city and value Fairfax city. And then I could do this for each one of the counties in my data set, specifically building out the label and the value. But there's a lot of them. There are actually 133 counties in Virginia. So that would be kind of tedious to have to build out 133 lines of code. There's a shorter way to do this, an automated way to do it. in a single line, which is, instead of Fairfax City, we call this is equal to a variable, x or j or whatever you want to call it. I'm going to call mine I. So label is equal to I, and value is also equal to I for every I in options list. And so that automatically builds out all 133 rows for my dropdown without me having to spell it out. And I'm just going to double check my data. I'm sorry, I have my bracket in the wrong spot. Apologies. The curly bracket goes here. Options list. And now I don't even need it to be on a separate line. I can just have the square brackets as so that now all those options fill into a single line. But just stop and reiterate one more time what we're looking at, and I'm going to hover over the elements. Options must always be equal to a list, which is why 34 has square brackets on either side of it. Inside that list, there must always be a dictionary that has to have two keys. It has to have the label and the value key. And what this is referring to is a dropdown displays labels and calls values in the back end, and they may or may not be the same. Oftentimes the labels are alpha and the values are numeric. But in this particular example, they actually happen to be identical. And then the for loop for I in options list just builds this out 133 times. So if that worked correctly, I go ahead and I save, and I wait for my debugger to run, and that worked. Now I've got a dropdown which will display all the counties. It doesn't actually do anything with that information, but my dropdown is functional. So at this point, I'm going to build out a simple callback in order to demonstrate how callbacks should work. Callbacks always have to have an input element, which is a drop-down, or maybe it's a radio button, or maybe it's a slider. There's a number of different input options that Dash has available. I've introduced to you to only the tip of the iceberg. There's actually dozens of some really cool ones that you can choose from, but 9 times out of 10, a drop-down is going to get the job done for you. So we've got our drop-down, and then we're going to add the output here, HTML div. It's going to be ID is equal to output div. And I forgot my comma, which is why it's not getting colored correctly. And names don't actually like hyphens, so we'll call it output div instead. They do like hyphens. What they don't like is me not putting it in quotes. Sorry. And for right now, we're just going to set children as equal to placeholder. And now I save that. And now we can see the word placeholder appears immediately below my dropdown. I'm going to update that now with the name of the county that I chose. But just kind of for housekeeping, it's nice to add a line break in there with an html.br. It gives a little bit of space between one element and the next, and maybe even one below it doesn't hurt as well. But look, I forgot a comma. Notice how the BR did not turn blue? That's Adam telling me, hey, you left something out there, Buster. You left out a comma. Failing to close parentheses or failing to add commas at the end of lines is 9 times out of 10 what's causing your Dash app to break. Okay, so I've got my output div. The children are currently placeholder. I got an invalid syntax which caused my app to crash, so I'm actually restarting it here in the bottom right-hand corner. And keep in mind that this debug equals true down in 54 is what allows my app to refresh in Chrome every time I hit save. If I didn't have that in line 54, I would have to manually stop and start every time I made a change, which can get pretty tedious. All right, so let's go ahead and add a simple callback. Callbacks always start with something in Python called a decorator, which is sort of like a funnel for the inputs of a function. Decorators start with the swirly A, and then the name of the app, which we defined earlier back in line like 12 as the name was going to be app or app. So I call it app.callback is a method. And here it's got to have two things. It's got to have output, comma, and then in a list, it's got to have input. And the reason this works is because up here, I imported input, output, and state from dash.dependencies. So I've got my input and I've got my output. And I don't really know why, it's sort of counterintuitive, but output always comes first. Where do I want my stuff to get displayed? Output receives a couple of options that go into parentheses. The first is, what's the name of the div? The div is going to be called output div. And then what portion of that div will receive the output? Well, always children. Up here, we defined children as placeholder. Now we're going to set children as blank so it can receive whatever the input is. We still got an invalid syntax because we haven't finished building out our results. And then our input will receive my dropdown. And the portion of my dropdown that it's going to get is going to be value, which we specified by default would be Fairfax, but value gets updated from the value in line 34 that's selected in the dropdown. So we've got our output, we've got our input, and the decorator looks nice. We're going to double check and make sure that our parentheses all match up by hovering over them. Outer parentheses, inner bracket, inner parentheses, that all looks good. So immediately on the very next line, without having any line breaks, we define a function. We're going to define this as county picker is the name of my function, and functions actually cannot have hyphens, they have underscores. I define county picker as receiving an arg. Now we saw args earlier. Really, I could have named it anything. What it's referring to is the value of my dropdown. But here the arg, maybe I'll just call it arg1 for precision. As long as I use the name consistently inside the function, it does not have to have the same name as what it had outside the function. And I'm simply going to return a simple string. Return f you have selected, curly brackets arg1. So this is clearly an f string, which will update depending on what a person has selected. I save this. I restart my Dash app down below. Wait for it to load. And make this a little bit bigger. So now we see that the default is Fairfax City, but if I move my drop-down to Dickinson County, my output updates accordingly. It's a very simple callback, but it demonstrates the logic of the callback, which is you've got your input in the drop-down that gets fed through this sort of black box change machine and then spits out to the output div. By the way, please do stop me if you've got questions or anything I can help clarify. Yes?
I'm confused about the children, the value, and then you deleted the children up there, the value, layout section. Can you just walk through that again?
Sure.
Okay, what's the meaning of children? Is it a child or parent or something?
So a div is a container, which is expected to have multiple containers inside it in a nested series. All of those contents are referred to as the children of the div. In addition to having children, it also has some other things, some other properties, specifically its class name and its ID. Its ID is its identifier, its class name is its layout, and its style is sort of its formatting, right? So if I wanted to, I could have actually added all of those in here. It also has style, which I'm going to leave blank, and it has class name which by default is going to be 12 columns. And those are sort of the four elements that a div can have. It can have an ID, it can have children, it can have style, and it can have a class name, which is its width and its size. But all of the meat of the div goes into the children, and that's where you can have other divs nested, or other figures, or even other drop-downs, etc. This div, which I've named output div, by itself has no children. Its children component is empty. But when it gets updated by my callback, its children get fed in. Its children become whatever was the return statement of my callback. So output div at line 38 updates its children depending on whatever it receives from line 52. So far, so good?
So 52, that function returns value, and that goes into 38.
Exactly. The value returned in line 52 gets displayed in the children component of line 38. And the reason that's happening is because at line 49, I specified that the output of the callback would go into the div whose ID is output div. And specifically, which of those four components? It would go into the children. It doesn't have to. You can actually update the style of a div using a callback, and that would change maybe the color or the size of your font or something like that. It's rare, but it's possible to do that. You could also update the class name, making it wider or less wide. But 99 out of 100 times, what you're going to want to update is the children. Okay? So that explains one half of your question. Your other half of the question is, what's all this value that's going on? Well, and here I don't have a lot of board space, but I am going to quickly sketch it out. I also don't have any lights. This is my callback. It has an output and it has an input, right? So everything that we just discussed was the output portion of it, which goes into children. It's outputting into children. But what it's getting inputted is the value of the drop-down div. So if we go back up here to line 32 through 34, this was my drop-down, right? My drop-down has a label and a value that the user can select. And it also has a component named value. The value component of the drop-down named my drop-down changes depending on what the user selects, right? Its default value is Fairfax City, but the user can change the value component to be any of the 133 counties. Line 35's value gets fed into my callback here at line 50 by the value specification. My dropdown is the name of the div, and the value is the name of the component in that div that the user can select. And here's the part that I think is highly counterintuitive. The value specified in line 50 corresponds to the value specified in line 34. That's pretty obvious because they're both named value. But it also corresponds to the arg in line 51. They're all the same thing, but they don't have the same name. arg1 in line 51 is exactly the same as value in line 50. But because it's a function, and in Python, functions have what's known as local scope, variables change their names inside the function. Now that I'm inside the function in line 52, arg1 maintains its name. It has to be consistent, but it's still the same. Value in line 50 corresponds to arg in line 51 and also corresponds to arg in line 52. They're all linked together. Yeah, they're in the back. Aiden.
All right, so I've got two questions.
Yeah.
Could you scroll up to the drop down? So value, that's just setting the initial value when the user opens the...
Line 35 is, yes.
Right.
But line 34 provides the
List.
list of options that the user can then choose.
Right. So basically, that knows that that's just a preliminary value and it'll be replaced if the user selects a different option.
Yes.
So you have to set it to something
No, you don't.
initially?
Here, let's see what happens if I just set it to blank. Or even, you know what, I'm just going to comment it out altogether, which is the same thing. Save. And now I get a, oh yeah, I shouldn't have done that, sorry. I can't leave that blank. That's what I get for screwing around with my code. Okay, and now that I've left it blank, notice that I've selected none. See how it says none? And the drop-down is also simply on the default word select. But now when I change it to Alexandria, it updates accordingly. So that's what line 35 is doing. It's actually unnecessary to have it at all, but it's sort of a nice cosmetic touch. The real workhorse is line 34.
Got it. So my second question, in my output div, I still have children equals the string placeholder
Yes?
in my mode, but it seems like that's just overwritten by the output of my callback.
Exactly.
Okay.
That's exactly right.
So you can have whatever you want there. It doesn't matter. The children of that div
Is going to be overwritten, yeah. My guess, though, is that if you set value at 35 equal to blank, then I'll bet placeholder will come back. Let me see. No, it doesn't. It still gets overwritten by none. Interesting. So yeah, this is actually unnecessary to have this at all.
Okay.
Other questions before I go forward?
Scroll to options.
Tell me which line?
There.
18? This one I didn't go into quite as much. This is just a pandas trick. But if you play around with it in the Jupyter Notebook and break it down into its smaller parts, I think it becomes obvious what it's doing. All right, so at this point, we have an app that simply allows us to select county names, but it's not actually displaying any output, which is where we want to go ahead and change a couple of things here. First of all, instead of a, oh, there's a number of different ways to do this. I'm sorry?
There's someone out there.
Oh, somebody out there. So I am going to change this from a div to a graph because I don't just want it to give text. I want it to display a graph. And instead of output graph div, I'm going to call output graph. And I'm going to get rid of the children altogether. I don't even need to have that here. So now I've got output graph. And I'm also making that change at line 49. And instead of children, an output graph now has a figure. So I save this, and I'm probably going to get an error message. Yeah, because it's HTML component. It's DCC, dash core components. Okay, and now it's running. Refresh over here. And now it's giving me an error message because I haven't actually displayed anything in it yet. But we'll come back to that in a second. So we're going to change what County Picker does here at line 52. First, we're going to create a data frame, which is a subset where jurisdiction is going to be equal to whatever was selected, arg1. And then I'm going to toggle back over to my Jupyter Notebook and get the code that I built out earlier for this nice graphic. All of this. In fact, I could just choose the entire function. but I'm going to choose the lower half of it because I think I toggled the variable names a little bit. So all of this, eyeball it, make sure I didn't have any mistakes. That looks all good. I'm copying my function, and I'm pasting it into my app, bringing back Chrome and making Chrome small. Unexpected indent. My data 1. Save. Rerun. Refresh. What's the error message here? Output graph. All right, it's telling me that it's having trouble with this. I want to make sure that I've got exactly the same name without any typos. It's outputting to the figure. That all looks good. My drop-down value. I know what it is. I built this great figure, but I forgot to return it at the end. I have to add the words return fig, and I save. That's what I was missing, of course, because a function must always end with a return statement. Let's go ahead and make this small so that it all fits on the same screen. Jurist name is not defined. Right, because it's arg1. Okay, and here we go. Looks like it's functioning correctly. I choose Alexandria, and it displays appropriately, and that actually worked. Choose a different one, and that also works smoothly as well. So the big step that I just took there was to change my function, and here I'm going to make it big so we can see it easily. This previously was just a simple function, and it said, what did it say? It said define county picker arg1 return f you picked arg1, right? So the only really big change that I've made here is that I've replaced these two lines of code with this much larger set of code that I tried out in my Jupyter notebook. What I guess requires a little bit of practice is that most of the time this would have been, we would have built this out not using a function, but simply as a kind of a static image. But here we've added the arg1 element so that the figure can be updated, and where it's updating specifically is any place that calls jurisdf. So line 56, line 57, down here at 60 and 61, and in arg1, all of those are now iterable elements that are coming from my function. Should I spend some more time on that, or can I move on now to the map element of this one? I see some nodding heads. Stop me here if you want me to go back over or talk a little bit more about how this figure is built out.
I broke my code. Can you just send us that?
Well, I can. You do actually have it.
Oh.
What I'm building out is, where is it? It's in Slack. So this Virginia election repository actually has 3 versions of the app in it. It has app 2, and app 3, which is exactly what I'm following from the other screen here. I'm just trying to kind of build it out element by element, so you do definitely have it. But at this point, well, let me ask this. How many people are able to get this to run successfully in their browser right now? Okay, a couple of folks. And others have been sort of following along and maybe might come back to the video in order to watch it again later on. Okay, and try this kind of on your own. So this is, at this point, I would stop and I would deploy to Heroku and make sure that this actually goes through the system and that my requirements, DXT, et cetera, works. But given that we've got about 30 minutes left, what I really wanted to get out there was the map element of the app. So let me talk a little bit about that. All right, so I'm going to Control-C. I'm going to stop my app. I'm going to list what's in here. I've got app.py, and I'm going to copy it. I'm going to copy app.py, and I'm going to call it app2.py, and I'm going to open that up in Atom. And now I'm going to clean house. I'm actually going to get rid of most of what I added so that I can add the map. All of this function, I'm going to get rid of it for right now. And instead of my output graph here, yeah, that can stay. So all of this stays. The only thing I got rid of was my callback. And now I'm going to run app.py python.2.py. And I refresh over here on the left. And now my dropdown still works, but it doesn't actually update anything. I've just got this blank graph. The blank graph is because at line 38, I have a dash core components graph.
What did you remove?
The callback. I deleted the entire callback and nothing else. And when you have a DCC graph with nothing in it, it just displays this placeholder X and Y axis because it's pending something else. Now the final thing is actually going to be a map. It's not going to be a scatter plot at all, but this is the default. So how do we build out that map? Let's see here. So first I'm going to add an import because I'm going to use this later on. I'm going to add numpy as NP. And then this all looks the same. Don't actually need this print statement anymore. But here we go. Up here at about line 19. Near the top of my app is where I put in all sort of the preliminary stuff. My pandas work, my definition of variables, and we are going to read in some JSON files for county shapes. And here, and this is boilerplate code that you would use in almost any map app. So from URL library.request, import URL open. This will allow me to open a URL and download the data that's in that website. And then I'm also going to import a library called JSON. These don't require any installs. They don't have to be in your requirements.txt because request, JSON, and URL lib are all part of base Python and Anaconda. So you don't actually have to install them, you just have to import them. And then we're going to open this up as follows with URL open, that's from line 20, and then I pass in the URL, which is a rather long one here. Do I have this at my fingertips that I can slack it out? I believe I do. Here it is. So in app.2, I'm just going to copy the URL because it's kind of long, and I will also slack it out. JSON shape files. Okay, so dropping that URL here in line 22, and I'm going to call this, I'm going to give it an alias. I'm going to call it response. You could have called it anything. I'm going to set a new list of values called counties, loading the response file that I just downloaded. So now I have counties, and if I really wanted to, I could print counties to see what it looks like. It's extremely long, so I don't think I'm going to do that. But it's basically it's shape files of all the counties in the United States.
Can I see the end of the URL open line? Okay, thanks.
Yeah. Okay, so scrolling back here, all of this I just added. Everything else remains the same, except the callback is going to differ. So I'm going to rebuild my callback as follows. The swirly A is the beginning of the decorator, that is to say, the funnel that feeds into my function. APP is the name of my Python script and my dash app, which I defined, as you remember, back up here in line 27. I said that app was how I was going to name my dash app. So I have to reuse the same name in line 53, and for what it's worth, also in line 58. The callback is a method. The output, just as it was previously, is going to be output graph. And the element of output graph that gets updated is the figure. And then the input must always be a list. Does anybody remember why inputs are always lists? It's because there can be a bunch of them. It doesn't have to be just one. Input. Sorry, input is not inputs. Input. And the input is just as it was before, my drop down, comma, value. And I double check to make sure I've got parentheses, brackets, and parentheses again, and they all have mates. Now I'm going to define my function. I'm going to call this one county highlighter. The name will never get reused, so it doesn't really matter what you call it. And once again, I'm going to call in the arg1. Arg1 refers to the value of the dropdown. And here's where it gets a little hairy. First, I'm going to create a new column in my data frame called selected. df selected is going to be a series of zeros and ones using the np-where method as a filter, where the jurisdiction column is equal to arg1, then the selected column should be at 1. In all other instances, it should be a 0. That's how np-where works.
What is NP?
np-where is similar to .map. It's a way of building out a new column. Maybe this is better displayed in a Jupyter Notebook. So, quick sidetrack to re-explain. I talked about np-where in the last class, but I'm going to redefine it here. How to build out a new column using a filter. Okay, so we have a data frame called, in this case, it was new df. Not defined because I have to run all above. Okay, so this is my current data frame. And I want to add a new column to it called selected. It's going to be equal to 0. And now when I call new df.head, see how I just added this column over here called selected? And currently it's all zeros. But what if I want it to be a 1 every time that a specific county comes up, like Accomack? Well, instead of setting it to 0, I use np-where. np-where new df jurisdiction is equal to Accomack County. Then the selected column will be a 1, and in all other instances, a 0. And I didn't import NumPy. There it goes. And now it's a 1. But if I were to scroll down a bit, you'll see it's 1 at first, but eventually it starts becoming zeros once I move into Albemarle County. Okay, so that's what NPWare is doing, and that's what I just created in my app. Okay, so the first element of my function was to add that filter, to create that column. And now I'm going to build out a figure. And in the interest of time, rather than live coding this, I'm just going to copy it from the solution, which is here in app 2. So all of this, I'm copying. I'll talk about it, but I'm not going to hard code it because I'm just going to do some fat finger errors. So what is this doing? So it's creating a figure using a new Plotly method which we haven't seen before, Choropleth Mapbox. In Tuesday's class, we saw the density heat map box function, which is similar to this, but it's kind of a different style of map. And it has several elements. The GeoJSON refers to the underlying map prior to my data being superimposed on top of it, which is why previously we imported that JSON file of county shapefiles. That's getting used here as my base map. And then on top of that base map, I map a second layer, which is the FIPS counties that are specified in my data frame. FIPS is the code that every county has with it. And then on top of that, there's yet another layer. This is the coloration layer, which is my selected column, which is currently just zeros and ones, right? I could have set it to a specific color scale, but I just went with the default because, to be honest, this caused me a lot of problems when I was playing around with it this afternoon. So I leave color scale unselected until I can figure out the proper name. And then everything else on top of that is just unnecessary but cosmetic. I have some hover text, I scale from 0 to 1, and I specify that the counties should be separated by a half pixel line. And then down below that, I have a few other cosmetic elements. I set the style to a out-of-the-box mapbox style. I zoom in to level 5.8. So level 1 means you're showing the entire world. And level like 15 is basically street level. 5.8 is about halfway down that. And then I center it on Charlottesville in order to get roughly the center of the state of Virginia. And I don't give any margins around it, though I could have. For right, top, left, and bottom. But again, everything from line 61 down below is actually optional. And if I were to delete those, my map would still work smoothly. The heart of it is simply the first 3 lines, 57, 58, and 59. Those are essential, and everything else is optional. And at the end of my function, as always, I finish with a return statement where I return the entire figure that has been built out by my function, because back up here at line 57, I said this entire thing would be a figure named fig. And where is it going to output to? Well, it's going to output to my output graph. If I did all of that correctly and I save, and I go back over to here and I refresh, and it's still set on none. There's Virginia, very nice. And now if I pick a county, and I wait and count to 10, it shows up in yellow. And then I choose a different county, and now that one shows up in yellow. So it's just a way of quickly highlighting, and if this were, if I hover over it, it gives the name of the county. And the reason it's doing that is because I specified that the text would be the county name and the hover info would be equal to the text that was defined in line 61. So you could actually have a whole ton of hover info specified there at line 61 if you wanted to.
How does it know to call that specific function?
I'm sorry, one more time?
How does it know to call the county highlighter? Scroll up on line 53. How does it know to call line 5?
Yeah, excellent question. Excellent question. So this gets into the heart of what a decorator does, and you've heard me use that term a number of times without me actually defining it very much. So about halfway through the class, maybe 5-6 weeks ago, we spent a lot of time on functions, right? And we talked about how functions will always receive an argument, and the user has to define what that argument is. Well, if you put a decorator immediately previous to a function with no space in between and no other intervening code, then that is a Python shorthand way of saying, here's what the inputs are going to be, here's what the arguments are going to be. So basically, lines 53 and 54 all together get condensed into line 55's argument. So it's not so much that line, yeah.
Line in between them, right? That breaks it?
Yeah, and about that, I'm pretty sure that a blank line will break it. I'm confident that more code will definitely break it. So if I were to put a print statement in here, then you would have a problem. But I think even a blank line will break it. I've always seen it snugly right up against the other because it's part of the function. So does that answer your question a little bit? I'm going to say it a different way for my own sake as well. You asked, how does line 53 know to receive the output of line 55? The reason it knows is because all three lines together work as a single unit of code, which is why they cannot be separated. All right, we are at 15 minutes. The last step in all of this was to put the map and the bar chart together into a single app, which is what app.3 does. So let me call that up, and rather than live coding it, let me just type out some of it and talk about how that worked. Yeah, it's right here. Control-C, app3. Oh, because we're in dash template, that's right. Let's do this. Okay, so this is the code that brings it all together, and by now much of this should be pretty similar. We read in our pickled data file. We read in those county shape files. Here we have our drop-down, but what's new is that now we have two output graphs instead of just one. We have 37 and 38. One is called display map, and the other is called display value. Other than that, the first 43 lines of code are identical to what we've worked with before. What's different is the callbacks. I now have callback 1, which is all of this. That's for the map. And I have callback 2, that's all of this, which is for the grouped bar chart. The map function, as we just talked about, receives from the dropdown and outputs to the display value. I've actually got that backwards. This is actually supposed to output to display map, and this one is supposed to output to display value. Oh, no, I'm wrong, sorry. It definitely, okay, this is the bar chart, so I wanted to go to display value.
Those variable names are set for particular graphics?
The variable names in 47 and 48?
Yeah.
So display value must correspond to the ID in line 38.
But it could be anything you want to specify, right?
You mean could I trade them? Or could I change? I could have called this, sure, Nats will win, right? And that's fine as long as I'm consistent with it down here in line 47. Those are the only two places it will appear, right? So my bar chart receives from display value, receives from dropdown and outputs to display value. And my map also receives from dropdown, but it outputs to display map. So we have kind of a bifurcation here. Both callbacks are taking in the same input, but they're pushing to two different outputs. And that's why in the final version, if I go back over here to Chrome, and I don't actually have it running anymore, so I'd have to fire it up. But in the final one, you have just the map and then the bar chart immediately below it, and the drop-down serves both of them.
Austin, can you go back to the code?
Yeah.
The two callbacks aren't really named explicitly. Is that because they're both wrong no matter what? Yeah.
That's a good point. I never really thought about that. I have a coded comment here calling it callback 1 and callback 2, but that's obviously just for me. I don't actually give them a name. I think the reason for that, and here I'm thinking on the fly because I never really thought about it, is the callback is actually one with the function, and the function has a name. I even tend to think of it as callbacks have functions, but it's actually the other way around. Functions have callbacks, which is why the callback doesn't get a name, because it essentially has a name, which is Juris Picker or Juris Highlighter. What do you think?
So if you had two different the function was the same name, both callbacks, that would be great.
Ooh, that's a good question. Let's find out. Yes, if what I said is correct, and I call this Picker, then we're going to have a problem. Let's find out. This is app 3, Python app 3. No, it actually seems to be cool with that. But let's wait and see if it actually outputs. To Bedford County, the map is always a little slower. It does seem to be having trouble with that. Look at that. I wonder if it's just slow on the draw, or if it's because I used the same name and the map comes second. I would have to do some further reading, but my guess is that they would need to have distinct names. And I do know this with confidence, that outside of callbacks, just in a standard Python script, your functions absolutely have to have different names. So my guess is that's why the map is not displayed.
Do you have more than one function listed in each of the callbacks, or is it just one?
Oh, and they're proving me wrong. Look, it's playing with me. Okay, everything I just said is wrong.
Could it be that because they have different outputs? Output names, I mean.
I honestly don't know why. I didn't think it was going to do that.
The best practice is just the name of it.
Yes, best practice would be. I'm sorry, you had a second question.
And then, can you have more than one function for a callback, or is it a one-to-one relationship?
I'm 95% confident that it is one-to-one. I have always seen and used a one-to-one correspondence.
Is the sequence matter?
No, sequence absolutely does not matter. And just kind of by industry practice, the order is the following, but it doesn't have to be this way. I always read in my data and define my variables first, initiate the app second, define all the layout third, and do all the callbacks last. But in fact, those elements could be completely rearranged, and I think it would work just fine.
So you can have the callbacks first that you want? Sorry.
I don't know. I'm just spitballing here.
Okay.
I think you could. All right, let me show you one more thing. And this kind of would be, I guess, for self-study, but I put this together so that you can use it as you work on your final projects. Another Virginia County app is here. This is in the General tab on census data. And again, this would make a nice, simple final project. So you could definitely use this as a template if you wanted to. And hopefully it's going to be more than just a white screen here. Come on. There we go. Okay, so in this one you have a map of Virginia, and then you can choose from any number of other variables, such as poverty is a good one, right? And it color codes the counties with this scale on the right-hand side showing where poverty is more extreme in the Southwest, or where commute times are higher in the Northeast, right, or where you're more likely to use transit, etc. So again, just a simple map with one callback. And the code is very similar to what we worked on tonight. All the standard stuff. Under resources, there is a couple of Jupyter notebooks that walk through how I built the data. And then under app.py, a lot of the same things that we had tonight. Above all, a DCC graph and a callback that ends up with the return fig statement. What this one has that the other one doesn't have is it has a lot of the class name activity going on so that things can be stacked horizontally as opposed to stacking them vertically. That's what lines 50 and 55 are getting at, is that horizontal stacking of your app. So again, this is out there if you want to use it as a potential template for your final project, or also this other one of the political data from 2016 is a good one as well. So let me stop my yammer there, turn it over to you guys. Are there any other final questions or things that you'd like to see, or just stuff that's kind of banging around in your head as we get into the home stretch of this class?
How did the class numbers work?
Sorry?
How did the class numbers work?
Great question. Okay, so here we have an outer div that starts at line 41, and it stretches all the way down to line 55. And we see that this div is obvious because of the indentation, right? So at 41, it's got kind of 4 spaces of indentation, and likewise at line 55. But what's really important is that at the end of all of it, the outermost div is 12 columns. So the idea is that because the app needs to resize to any screen or even a smartphone, we wouldn't want to hard code it to a specific number of pixels because obviously that would render differently from one screen to the next. So everything is thought of as a maximum of 12 columns, which can get subdivided into any combination of 12, 1 and 11, or 8 and 4, or 6 and 6, etc. So inside this div of 12 columns, I have 2 other divs. The first is from line 43 to line 50. And this div has a bunch of stuff in it, but at the bottom it has a class name equal to 3 columns. So of my outer one that's 12, the first 3 are for the dropdown, and the other 9 are for the map. So it has to add up to 12. If it doesn't add up to 12, or if it adds to more than 12, stuff will not get displayed. You won't get an error message, you just won't see it. So you need to make sure that it adds up to 12. And obviously you could do this, it doesn't have to be 2, it could be 3 or even 4 divs, as long as their column names, their class names always add up to a total of 12 columns. Finally, the default is 12 columns. So unless otherwise specified, every div is 12 columns. So even the ones that aren't, for example, this div up here, this one's 12 columns. It ranges from 38 all the way down to 63. And this is a div, and it's 12 columns. And the line break is 12 columns. So all of them by default have a class name of 12. Yes?
If the default is 12 and you have a div and a div of 3 and 9, is it even necessary to add that class name 12 columns at the end?
In theory, it's not. But I remember early in my learning career with Plotly, I ended up having problems when I didn't specify it, so I started doing it all the time.
Yeah.
My guess is that it's probably not necessary, but I guess I do it for cleanliness.
Thorough.
Yeah.
And then the commas and stuff? Is that-
The commas are just, they're going to kill you. It's so easy to lose them and forget them, right? But when do you need columns? Basically at the end of every, not every line break, but the end of every element. So for example, at line 52, I don't need a comma because in fact, the parentheses don't end until here, right? Which is why I also don't need a comma at the end of line 53.
Can you say that again? Sorry.
Sure. Maybe I said that poorly. Everything that's currently highlighted is a single element. So at the end of it, I need to have a comma. Commas don't represent line breaks. They represent the end of elements. However, the final element doesn't need to have a comma, which is why, because line 53 is the only element inside of its div, it doesn't need to have a comma. But if I were to put another graph immediately below it, then I would have to separate them with commas. Or put another way, this comma is unnecessary because nothing follows it.
And, is there a reason why the HTML div 52 and line 53 and the white space is where it is, and the comma 54?
Oh, yeah, so that's unnecessary, but, and again, this is really, it's just me. Other people might code it very differently. But I like to have a visual white space on the left showing me the nested structure of my divs. So whenever a new element exists inside a higher level element, I make sure to put it on a new line with a break. However, it's not necessary to do that. All of this would actually have fit very neatly onto a single line. Also here, I do the same thing with all of my red options. You don't need to do that. I just find it to be more readable that way. Okay, any last words? Well, great. I hope that was helpful. Again, this recording will be posted on YouTube. Feel free to hit me with questions over Slack. And please do get started on your final projects now so that you don't leave it as a big crush for the very end of class. Thanks a lot. Really appreciate your time, and I will see you guys on Tuesday of next week.
It's awesome.
Thank you.
Thank you.
Thank you.